So remember the vertical line test to see if something's a function? Today we're going to figure out if the inverse of something is a function. And this time we're going to use the horizontal line test. So let's pretend like we were just trying to figure out if that blue line is a function. We would do the vertical line test and it would fail. So the blue original function would be a no, it's not a function. Alright, I'm just going to jot this down over here. Original no, because it fails the VLT. But we want to see if the inverse of that is a function. So we can use the HLT, the horizontal line test. So this time, we'll look at that horizontal line they drew. It only crosses the function once. We can look at that horizontal line. It only crosses once. And so the inverse would, yes, be a function. Why? Because it passes the HLT. Alright. Another way to think about these, besides using the horizontal line test, is if you were to rotate your paper 90 degrees. So I can't rotate this paper, but if I were to take that graph and instead of drawing it the way it looks, if I were instead to flip it so it kind of looked like that, would that then pass the vertical line test? And the answer would be yes. Either way, the inverse is a function. It's just as easy to use the horizontal line test though. So let's just consider the original function. The original is the line that we see. Would that one pass the vertical line test? If we drew a bunch of vertical lines through it, the answer would be yes. It passes the VLT, the vertical line test. Let me get those out of there now. Now, to see if the inverse is a function, so now we'll say inverse. Is the inverse a function? We'll see that horizontal line they drew. Oh no, it crosses it 3 times. So the answer would be no. The inverse of this function is not a function because it fails the HLT. If we were to rotate that graph and draw it sideways, you would see that that would fail the vertical line test and we would come up with the same answer. Alright, now what if we want to actually write the equation of an inverse rather than just pretend like we can picture the graph being the inverse? To figure out what the equation of the inverse would be, you switch the x and y values. You just flip-flop them. Once you do that, you solve for y equals. So let's do that. Example A. F of x is the same thing as y equals. So we have y equals negative 5x plus 20. That's the original. But what we're going to do is switch the x and the y. So instead of y, I'll write x. And then I write the negative 5. Instead of the x, I'm going to write y. And then I write the plus 20. So we switched the x and the y. Now we're going to solve it for y equals. So the y's right there. Let's get rid of the 20 by subtracting it. So we're going to have x minus 20 equals negative 5y. And then to separate the negative 5 and the y that are times together, we'll have to divide everything by negative 5. So the final answer, now that we have y all by itself, is y equals, this is going to be a 1 in front of the x, 1 divided by negative 5, so negative 1/5 x, and then negative 20 divided by negative 5 is plus 4. So there's the equation for the inverse of the original function f of x right there. Let's try example B. So right now, it's y equals x squared minus 25. We're going to flip-flop the x and the y and write x equals y squared minus 25. So now the goal is to solve it for y. So let's get rid of the 25 by adding it to both sides. So we have, I'm going to have to move this over, x plus 25 equals y squared. One more step to get the y all by itself, and that is to square root it. And we'll square root the other side, and you can basically leave your answer just like that. The square root of x plus 25. And you're done. Alright, now for C, we will do the same thing. We'll flip-flop the x and the y. I'm going to start off by writing x equals, and then I'll just write the y right in the x spot right there. I'll copy the minus 4, and that's divided by 3. So we want to solve it for y. Alright, let's get rid of this pesky fraction. That whole side's being divided by 3, so we'll multiply by 3 to get rid of it. So we'll have 3x equals y minus 4, and then we'll add 4 to both sides. So the final answer here will be, now that y is all by itself, 3x plus 4. And we're done. Let's say we're given two functions like f of x and g of x, and we want to figure out if they're inverses of each other. We can do that by taking the compositions. If we compose f of g of x, and it equals some number, maybe x, and then we compose g of f of x, so we do it the other way, and that equals the same thing we got the first time we composed it, then the functions are inverses. So basically we have to do two compositions. So first let's do f of g of x. So what we're going to do is plug the g function, plug all of this into the f function. So the f function is 2x plus 4, right there. So we're going to take what it says that I underlined in red and plug it in right there for the x. So I'll copy the 2, and now I'm going to start parentheses because whenever you plug something in for x, you should put it in parentheses. So in those parentheses, I'll write the 1/2 x minus 4. And then I'll keep copying the rest, the plus 4. And so now I need to distribute. 2 times 1/2, those 2's are going to cancel out, so I just have x, 1x, and then I'll do 2 times negative 4, which is negative 8, and then I have the plus 4 over there, so this whole thing equals x minus 4. Alright, let's see what we get when we do the composition the other way. This time, let's do g, oops, I'll use red. We'll do g of f of x. So we're going to plug the blue f part into the g equation. So the g function is 1/2 x minus 4. So we're going to take the blue f of x and plug it in for x. So that will look like 1/2. And then in parentheses, we're going to plug in the stuff we underline in blue, the 2x plus 4. And then we will subtract 4. So let's distribute. We're going to get 1/2 times 2 is 1x. 1/2 times 4, well, half of 4 is 2. So we'll get plus 2. And then we have minus 4. So this becomes x, and then 2 minus 4 is minus 2. So we did not get the same thing for both of those. So the answer is no. These are not inverses. Let's try the next one. We're going to do the same thing. We're going to compose those both ways. Alright, the first way will be f of g of x. So let's write that down. The f function is 1/4 x squared, And the g function is 2 square root x. So for the g function, we're going to write down the stuff that I just underlined in red. So we have 1/4, and now in parentheses, I'm going to write 2 square root x, and I'm going to square it. So we replaced that x with what I underlined in red. Now we need to go through and distribute. We should do, I'm sorry, not distribute, we need to distribute the exponent first. So we have 1/4. We'll put that little exponent on that too, and 2 squared will become 4. And then we're going to put a squared on the square root of x, and that's going to cancel out. So this will become 1/4 times 4x. And when you multiply 1/4 by 4, you get x. All right, let's do this the other way now. Let's compose g of f of x. All right, so we're going to write the g function. We're going to write the red one, 2 square root x. And for the x, we're going to plug in the blue f function. So this will be 2 square root, and now we're going to write what I underlined in blue, 1/4 x squared. And now we simplify. We have the 2 out front. Can we square root 1/4? Can we square root the top and square root the bottom? Yes, we can. The square root of the top will be 1, and the square root of the bottom is 2. And then the square root of x squared is x. So the last step is to multiply 2 times 1/2, and that just gives us 1x. And so since we got x and x for both of these, our answer is yes, these are inverses. Good luck on your homework.